Gottfried Wilhelm von Leibniz defined a quantity called living force to be the mass times the speed squared of a moving object. If a 2,225 kilogram car is moving at 15 meters per second, how much living force does it possess exactly? Now, maybe I just want to throw out there really quickly, we don't actually use living force anymore in physics, but it is an interesting quantity that it turns out is closely related to the modern day definition of kinetic energy. So in that sense, it is a close cousin of one of the forms of energy. But it tells us the formula right there because it says mass times speed squared. In other words, maybe if I were to write that as a formula, it would be just m. We use v for speed, of course. So mv squared, I think, is what we're talking about there. That's that living force thing. And hopefully this isn't sounding too Star Warsy as I say that. But anyways, what we're going to do here, though, very simple calculation, I think. But the cool thing is it's going to show us maybe a little bit already something with units, perhaps, because we have 2,225 kilograms for mass, and naturally we have 15 meters per second squared, since it says speed squared, right? And that's what the formula says. So now we can go into the calculator to actually see what number that gives us. So maybe we won't worry. This is a kind of historical example, so I'm not going to worry about rounding off rules for this too much. The exact value I get is 500,600. Let me make that 6 look a little bit better there. Okay, there. Well, sort of better. 625. And then the units would be kilogram, really meters squared per second squared. Okay, that's an interesting unit. Turns out, if you look closely, though, maybe another way we could look at this. So 500,625. A kilogram meter per second squared is a newton, but we do have an extra meter up here, so maybe this could be looked at as a newton times a meter. What else could we say? Well, let's go ahead and look at the answer here. It says 500,625 joules, so that's that named unit that we use for energy. And it turns out the living force, like I said, is kind of a distant cousin perhaps of a modern day defined form of energy. It's in fact exactly double the modern definition of kinetic energy, which would be 1/2 mv squared is the modern definition of kinetic energy. And I guess as a joke I put here, may the living force be with you. I guess that means that I'm saying keep moving fast.